Hello, so today we're going to be working with dividing with scientific notation. Now what makes this particular lesson different than the ones that we've already had is the fact that you're going to see the division that takes part with these problems aren't going to work out nicely. So we're going to look at how do we round, what do we do, what does it all mean? So with that, let's go ahead and jump into our first example. It says to divide and make certain the quotient is in scientific notation. And then we have 8.2 times 10 to the fourth divided by 6.7 times 10 to the negative second. So the very first thing that I want to do is actually group the coefficients into one group, as well as group the tens into one group. Now it's going to be just a matter of simplifying the coefficients and simplifying the exponents to see what our final answer is. So with that, let's go ahead and get started. I'm going to go ahead and do some side work on what 8.2 divided by 6.7 is. So let's go ahead and write that out, 8.2 divided by 6.7. Now, with dividing decimal, it is important to turn the decimal into a whole number. So in order to do that, we're going to have to move the decimal once to the right. If I did it on the outside, I'll also have to do it on the inside. So once I've done that, I'm just going to bring the decimal straight up. Then I'm going to start dividing. Can 67 go into 8? No. So let's put a 0 up there. Can 67 go into 82? Yes. And hopefully you can see that it can go in once. So with that, we're going to go ahead and subtract. This is going to be a 12. We're going to borrow from here, leaving us with 15. Now, it obviously didn't go in nicely, so we're going to have to bring down a 0 and continue dividing. Can 67 go into 150? Yes, but how many times? Well, I don't know about you, but I don't know multiples of 67 off the top of my head. So for that reason, I'm going to go ahead and round. And I'm going to say, hey, 67 is pretty darn close to 70. So maybe let's do multiples of 70. How many 70s would get me closest to 150? I would say 2 times. Why? Because 70 times 2 is 140, and that's pretty darn close. So let's go ahead and try 2. Notice when I'm trying 2, I'm still using the actual number, which is 67. I'm not using 70. By multiplying, that's 14. Carry the 1. That's 12 plus 1 is 13. Now that's pretty darn close. So let's go ahead and put a 2 on top of the 0 to indicate that it's going to 150. Let's find the difference. And once again, you're going to find that it does not go in evenly. So what do? Well, on the homework, if things do not divide in evenly, it is going to instruct you to round to the nearest tenth. So let's look at what we currently have. Here is our tenths value. It is a 2. Now, when you're rounding, it is important to have the next digit. Why? It's important to have the next digit because this digit will tell me whether or not this 2 is going to get rounded up or if it's going to stay the same. So do you know what that means? It means that we're going to have to do one more division. So let's go ahead and bring down another 0. How many times can quote unquote 70 go into 160? I would still say 2 times. Why? Because 70 times 3 is 210. Which I think is a little too much. So let's go ahead and use a 2, which is 134. Okay, and that's still going to leave us with a remainder of 26. But you know what? This is enough information. I know it doesn't go in evenly. I'm just going to go and put ... to indicate that it didn't. But this is enough information for me to round to the nearest tenth. So let's go ahead and put that 8.2 divided by 6.7 is 1.22 ... times 10 to the, well, according to our properties, if it looks like this, we're going to have to subtract the exponent. So 4 minus a negative 2. So let's simplify the tens real quick. This is 4 minus a negative 2. I like to think of it as, hey, a negative times a negative is a positive. So I'm just going to change this to a big plus sign. So 4 plus 2 is 6. Now let's go ahead and bring down this 1.22 ... So again, just because it didn't go in nicely, I am going to be instructed on the homework to round to the nearest tenth. Here is my tenths value. So looking to the hundredths, would this 2 make the 2 stay at a 2, or would it bump it up to a 3? Well, in this case, it would keep it as a 2, so I'm going to say my answer is 1.2 times 10 to the 6. Now, notice again that this wasn't an exact answer. We did have to round. So to indicate that it's an estimation, we're going to go ahead and use the approximation symbol, which looks like this. So I would say the answer is approximately 1.2 times 10 to the 6. Now, I can go ahead and safely say that this is my answer because it is in scientific notation. My coefficient is between 1 and 10. So that means we're good. Okay, so now what's going to happen is I'm going to go ahead and do another example, and then I'm going to go ahead and have you try one by yourself. But before you try one by yourself, let's do one more. So it says here, divide and make certain the quotient is in scientific notation. So the steps are going to be very similar. We're going to go ahead and group the coefficients into one group. We're going to group the tens and the exponents in another group. So in order to figure out what this answer is, I'm going to have to do some side work. I need to figure out what 6.3 divided by 1.1 is. So let's do that. 6.3 divided by 1.1. When dividing it by decimals, it's important to turn those decimals into whole numbers. So in order to turn 1.1 into a whole number, we're going to move it once to the right. So we'll do the same on the inside. We're going to bring up that decimal. Now, can 11 go into 6? The answer is no, so I'll put a 0 right on top of the 6. Can 11 go into 63? Yes. Now, what's nice about this example is I actually know multiples of 11, so that's going to be a little bit easier for me to do in my head. So, how many times can 11 go into 63? I would say 5 times, which is 55. Let's find out what the remainder is. That's going to be an 8. Now that didn't go in nicely, so let's bring down a 0. Can 11 go into 80? Yes, it's going to go in 7 times, which is 77, which is going to leave us up with the remainder of 3. So now, as you can see, it's not working out nicely, so let's figure out how far we need to go. So like I said, in the homework, it's going to instruct us to round to the nearest 10th. So here's my tenths value. Now, in order for me to actually round to the 10th, I will need the next digit. Why? Because this next digit would tell me whether or not the 7 is going to stay as a 7 or if it's going to round up to an 8. So let's go ahead and take it one extra step and bring down another 0. So can 11 go into 30? The answer is yeah. How many times? It can go in 2 times. So I'm going to go ahead and say that's 22, and a remainder is 8. So just to show you it didn't work out nicely, it's going to continue. But I'm going to stop here because this is enough information for me to go ahead and round to the nearest 10th. So what did I get? 6.3 divided by 1.1 left me with 5.72. times 10 to the, and once again, the properties of exponent would tell me that I'm going to have to subtract the exponent, so we're going to do 4 minus 8. So I'm going to go ahead and simplify that real quick. 4 minus 8 is going to be negative 4. I'm just going to go ahead and bring this straight down, 5.72. Let's go ahead and put the dot, dot, dot to just indicate that it didn't work out nicely. So for that reason, I am going to have to round to the nearest 10th. Here is my tenths value. Will this 2 bump up the 7 to an 8, or will it keep it the same? Well, since it's a 2, it's less than 5. It's actually going to stay a 7. So I'm going to go ahead and notate that it's going to be approximately 5.7 times 10 to the negative 4th. So once again, I'm going to show that it's approximately. Why? Because the answer didn't work out nicely. This is an approximation. I did have to round my answer. And I can go ahead and confidently say that this is my answer because it is in scientific notation. My coefficient is between 1 and 10. Okay, so now we're going to do something a little strange. Now that I've gone over that example, I want to give you an opportunity to try one by yourself. And the one number that I actually want you to try is number 9. So you're going to have to skip around. So go ahead and try number 9. I'm going to go ahead and give you about 3.5 minutes to try this on your own. So you may begin now. Okay, so now it's time to go ahead and check our answers. So here, when you divided, okay, you should have divided the coefficients and then you should have grouped the tens together. Let's see what we would have gotten. You have 8.2 divided by 5.2. So what's going to happen? Well, first we're going to have to turn these into whole numbers, so moving that decimal once to the right. Can 52 go into 8? Nope, so we're putting a 0 there. Can 52 go into 82? The answer is yes, it can go once. And that's going to leave us up with a remainder of 30. So let's, we can obviously see it doesn't go in nicely, so let's bring down 80. Now, can 52 go into 300? The answer is yes, but how many times? Well, it's important for you to understand we don't know multiples of 52, but we can estimate and say, hey, 52 is pretty darn close to 50, so let's use 50. How many 50s is going to get us close to 300? Hopefully you're going to say 6, because 50 times 6 is 300, but wait, 50 times 6 is 300. So wouldn't 52 times 6 be a little too much? The answer is yes. So I wouldn't want to try 6. I would actually want to try 5. So let's try 5 to see what that gives us. That's going to give us 260, which I think is pretty close. So let's go ahead and put a 5 on top of the 0, which is going to give us 260. We're going to be left with a 40. So here, let's see. It doesn't go in nicely, so we're going to go ahead and check to see how far we're going to need to go in order to round to the nearest tenth. Here is our tenths value. It seems like we're going to need one other digit to tell us whether the 5 is going to stay a 5 or go up. So let's go ahead and continue dividing by bringing down another 0. So estimating again using 50, how many 50s is going to get us close to 400? The answer is 8. Why? Because 50 times 8 is 400. But wait, if 50 times 8 is 400, 52 times 8 would be a little too much. So for that reason, one more time, we're going to go ahead, instead of using 8, we're going to use the one below, so we're going to use 7. If we multiply that, we're going to get 364, which is pretty darn close without it going over. So let's go ahead and put a 7 here. And then you can see once again that it didn't work out nicely. But that's okay. Even though it didn't work out nicely, this is enough information for me to round to the nearest tenth. So I'm going to go ahead and write 1.57 times 10 to the, once again, hopefully you notice we're going to have to subtract the exponents. So the tens are now going to be raised to the negative second power. I'm just going to go ahead and bring down the 1.57. Note that it didn't go in nicely, so if you want, you can notate that using the ... Since it didn't work out nicely, the instructions on the homework will ask you to round to the nearest tenth. So this 7's purpose is only to tell me whether or not the 5 is going to stay a 5 or if it's going to round up to a 6. In this case, it will round up to a 6. So I'm going to say my answer is approximately 1.6 times 10 to the negative second. So notice, again, we're going to use the approximate symbol because it's not an exact answer. So I'm going to go ahead and claim that this is my final answer. Why? Because my coefficient is between 1 and 10, so we're good to go. So hopefully you got that right. Now we're going to go ahead and move on to another example that's going to be slightly more challenging. So we're going to go back to number 6. I apologize, we are skipping around a lot, but let's go ahead and do number 6. It says divide and make certain the quotient is in scientific notation. Just like before, we're going to go ahead and group the coefficients into one group. We're going to group the exponents in another group. Now all we're going to have to do is simplify to see what we end up with. We're going to have to do 5.9 divided by 7.2. We're going to first need to start to change this decimal into a whole number, so we're going to move it once to the right. We're going to have to do the same thing on the inside. Bringing up that decimal. Can 72 go into 5? No, so we're going to put a 0 on top of the 5. Can 72 go into 59? The answer is, again, no, so we're going to put another 0. So now I'm going to have to put a 0 here. Can 72 go into 590? The answer is yes. Again, I don't know multiples of 72. So instead of using 72, let's estimate and use the number 70. How many 70s is going to get me close to 590? Hopefully your answer is 8, because 70 times 8 is 560, which is pretty close to 590. So let's try 8. If we multiply by 8, we're going to get 576, which is pretty darn close without it going over. So let's put an 8 right here. We're going to put 576. We're going to find the difference, which is going to leave us with 14. So now we're going to see that it doesn't work out nicely, so we're going to bring down a 0. So here, 72, how many times will it go into 140? The answer is, let's see, rounding it to 70, I would say it would go twice, because 70 times 2 is 140. But if 70 times 2 is 140, 72 times 2, I think it's going to be a little too much. So instead of doing 2, let's do 1, which is going to be 72. So what's our remainder? I'm going to be left with 68. So now, again, you're going to see that it doesn't work out nicely. So let's see how far we're going to need to go. Now this one's different, so I need you to pay very close attention. In the last example, my answer was actually between 1 and 10. So that's why it was okay. But if you can look at our current answer, I can already tell it's not between 1 and 10. Which is going to mean that when we finally write down our answer, we're going to have to adjust this coefficient so it meets scientific notation requirements, which is it needs to be between 1 and 10. That means I'm eventually going to have to move this decimal once to the right to make it between 1 and 10, which means this is now my tens place. There is no number right here telling me whether this 1 is going to stay a 1 or if it's going to round up, So what does this mean? This means we're going to need another digit right here, because this digit is going to tell me whether or not the 1 is going to stay or if it's going to get rounded up. So for that reason, let's go one extra 0 to bring down and see what we end up with. So again, we're going to estimate how many 70s is going to get me close to 680. I'm going to say 9. Why? Because 70 times 9 is 630, and that's the closest I can get to 680. So let's see what we get there. It's going to be 18, carry the 1, 63 plus 1 is 64. So that's pretty darn close without going over, so I'm going to go ahead and put a 9 here. And as you can see, it does not work out evenly. It's going to keep going, but I think I'm going to have enough information here to go ahead and write an answer. So what happens when we divide those two numbers? I'm going to get 0.819 ... times 10 to the, remember in this case we're going to subtract the exponents. Make sure you write it correctly. It is minus a negative. I want to simplify the tens first. I'm going to go ahead and say a negative times a negative is a positive. So negative 2 plus 5 is going to give us a positive 3. I'm going to go ahead and bring this straight down. Now one thing again that's going to be different from this example from the previous one is you're going to notice that this is not in scientific notation. What that means is we're going to have to adjust it. In this case, we're going to have to make it larger. And by making it larger, we're essentially multiplying by a positive 1. But to balance things out, we're going to have to multiply this part of it by 10 to a negative 1. So what does this leave us with? 8.19 ... times 10 to the, we're going to add these exponents. 3 plus negative 1 is a 2. But as it indicates, it didn't go in nicely, so I am going to have to round to the nearest 10. So notice this 9 was necessary. If I didn't have this 9, I wouldn't know whether or not this 1 was going to stay the same or not. So in this case, the 9 is going to tell me that this 1 is going to bump up to a 2. So my final answer is going to be approximately 8.2 times 10 to the second. And that would be my final answer. So before we move on, I want to explain why this one is so different than the previous one. The main thing that makes this one different is the fact that my answer right here is not between 1 and 10. And for that reason, I knew I was going to have to make an adjustment. I knew I was going to have to move my decimal over once to the right, which means this was now the tens place, which means I needed another digit to tell me whether or not this 1 was going to stay a 1 or if it was going to bump up to a 2. So, rule of thumb is if you divide and it's not between 1 and 10, it's too small, you're probably going to have to divide all the way up into the thousands place. Okay, so now that I've done that example, guess what? It is your turn. So once again, we're going to skip around. I want you to go ahead and try number 10 by yourself. Again, I'm going to give you about 3.5 minutes to try it on your own. If you're unsure, please refer back to number 6. But other than that, go ahead and give it a shot. The time begins now. Okay, so let's see how well we did. So hopefully you went ahead and grouped the coefficients with one another and you grouped the exponents to one another. I'm going to go ahead and simplify by dividing, so 7.8 divided by 9.7. When we're dividing by decimals, it's important to first turn them into whole numbers, so 1 to the right to make it a whole number, 1 to the right, because we got to do the same to both sides. So, can 97 go into 7? Nope, so we're going to put a 0. Can 97 go into 78? Nope, so we're going to put another 0. So in this case, we're going to have to add a 0 here. Can 97 go into 780? The answer is yes. Now, I don't know multiples of 97, but I'm going to say 97 is pretty darn close to 100. So let's do multiples of 100. So how many hundreds would it take me to get close to 780? Some of you might say 7, because 100 times 7 is 700. But I'm going to say, hey, 100 times 8 is 800, and 800 seems a little bit closer. But I know what some of you are thinking. You're probably thinking, but wait, isn't that going to be a little too much? Well, let's check. Let's try 97 times 8 to see what that gives us. 7 times 8 is 56. Carry the 5. 72 plus 5 is 77. Guess what? It's good enough without it going over. So we're going to put an 8 on top of that 0. We're going to find the difference, which is a 4. Now, because it didn't work out nicely, we're going to go ahead and bring down a 0. So can 97 go into 40? The answer is no. So I'm going to put a 0. So that's going to be 0 with the remainder of 40. Now, should I stop or should I keep going? Well, let's check. This number is not between 1 and 10, which means I'm going to eventually have to adjust it so that it can meet the requirements of scientific notation, which means I'd eventually have to move this decimal ones to the right, which means this 0 is eventually going to be treated as the tens place. So I'm going to need an extra digit right after. Why? Because I need this digit to tell me whether or not this 0 is going to stay a 0 or if it's going to round up to a 1. So what does that mean? I'm going to have to keep dividing. So let's go ahead and do one more 0 to bring down. How many 97s is going to get me close to 400? So again, I'm going to treat it as if it's 100. So how many hundreds would get me close to 400? I would say 4. So let's try that. 97 times 4, that's going to be 28. Carry the 2. That's going to be 36. 36 plus 2 is 38. That looks good enough without it going over. So let's go ahead and put a 4, which is going to be 388. Guess what? It still doesn't work out nicely, but I would say I have enough information for me to go ahead and round to the nearest 10. So to simplify, I'm going to go ahead and say that I got 0.804 times 10 to the, we're going to have to subtract the exponents. Now to simplify, I'm going to say, hey, a negative times a negative is a positive. So that's going to give me 10 to the positive fifth. We're just going to go ahead and bring down this coefficient. Let's go ahead and remind ourselves it didn't go in nicely. So using the dot, dot, dot tells me I'm going to have to eventually round. But before we do that, I want you to recognize this is not between 1 and 10. It doesn't follow scientific notation. So I'm going to have to multiply by a positive 1. Why? Because I'm making the number larger. But to compensate, I'm going to multiply this part by a negative 1. So what does this leave me with? It leaves me with 8.04 dot, dot, dot times 10 to the. I'm going to have to add these exponents. 5 plus negative 1 is a positive 4. So you're going to see why this 4 was so important, why we had to divide all the way up until the 4. Because this is now the 10th place, like I mentioned earlier. This 4 is what's going to help me decide whether or not this 0 stays a 0 or if it rounds up to a 1. In this case, it's going to stay a 0, so my answer is approximately 8.0 times 10 to the 4th. Now what's going to happen is you're going to go ahead and go onto your exit ticket and try the problem that's there. Thank you for paying attention, and I will see you tomorrow.